Today's general rational functions, though, we might have higher exponents in the numerator and denominator, so not necessarily just like a little linear function over a little linear function. Just reviewing from last class how we found each of the following things. What did VA stand for? Vertical asymptote, right. Let's review how we did that last time for a general rational function. How did we do it? You set the denominator equal to 0. Equal to 0, and then solve it. And you'll get an answer that's like x equals and then some sort of number here. Okay, and then last time when we talked about HA, what did HA stand for? Horizontal asymptote, right. And for a general rational function, how do we find the horizontal asymptote?
Is it the A over C?
It is the A over C, yes. It's the ratio of the two leading coefficients. Ratio of leading coefficients. And since it's a horizontal line, it'll be in the form y equals, and then it was just A over C. A was the leading coefficient on the top, C was the leading coefficient on the bottom. X-intercept, how do we find the x-intercept of any function?
Set y equals 0.
Plug in y equals 0. Set y equal to 0. Good. Plug in y equals 0 and solve. So then the y-intercept would be plug in x equals 0 and solve. When we do both of these, though, how do we want to write our answers? As points, right. Write your answers as points or a coordinate, ordered pair, however you want to say it. Right. As points. Alright, there's a rundown of last class. The only thing different today is because when we have higher exponents, that means we might have a quadratic in the top or bottom, or maybe a cubic function in the top or bottom. So the first thing we're going to want to do is always factor them. That is going to help us find the vertical asymptotes and x-intercepts and y-intercepts easier. For each of the following, we're asked to find the vertical asymptote and the intercept. So we're skipping over the horizontal asymptote for these two. Again, anytime you see a quadratic on the top and bottom, the first thing you want to do is factor it. Factor first. Okay, so looking at this one here, I have x squared minus 4x over x squared minus 9. Both of those are factorable. The top is not super complicated to factor. It only has what? Only has an x factor. It only has a GCF, right. What is the GCF of the top? X. If I divide them both by x, what's going to be left over? X minus 4. Good. The bottom is a special type of quadratic. Anyone remember its name? Emma? Difference of squares, yes. Difference of squares. So the bottom's difference of squares would factor into
X plus 3, x minus 3.
x plus 3, x minus 3. Very good. Alright, there we go. We've got it factored. So I'm going to start by finding the vertical asymptote, the VA. On this one, we're going to take the denominator. We're going to set it equal to 0. Set denom equal to 0. So if I have two factors in the denominator and I set that equal to 0, how many vertical asymptotes are we going to have? Two, yeah. We'll look at how these look later, and they look weird. So I'm going to take that x plus 3, x minus 3. I'm going to set it equal to 0, which basically creates two answers. One when x plus 3 equals 0, and one when x minus 3 equals 0. So my two vertical asymptotes, one of them's at x equals negative 3, one of them's at x equals positive 3. On this page, we're not asked to find the horizontal asymptote, so I'm going to skip over that, and then I'm just going to get right on into the x-intercept. We wrote that down earlier. Remember, that's when y equals 0. Okay, so I'm gonna take the one that I factored and set this one equal to 0. I'm gonna have 0 equals x times x minus 4 over x plus 3, x minus 3. How do you think we're going to solve this?
We multiply the top by x plus 3, x minus 3.
Right, you multiply everything, both sides, by that denominator. Anyone notice what always happens to this denominator?
It disappears.
It always disappears, yeah. You think that would be a nice shortcut to use?
Oh yeah.
Yes. If you know the denominator is always going to cancel because you're going to multiply by it, it's going to cancel on the right, it's going to turn to 0 on the left, we might as well do a shortcut. What kind of shortcut that's going to look like? It's going to be just which part equals 0?
X.
It's just going to be just the numerator equals 0. So for the x-intercept, if you're plugging in 0 for y, you're technically just setting the numerator equal to 0. Because on the left it's going to turn to 0, on the right the denominator is going to cancel, and we'll be left with just numerator equals 0. So if I have two factors in that numerator that both equal 0, how many x-intercepts are we going to have? 2, yeah. So one of them is going to be when x equals 0. One of them is going to be when x minus 4 equals 0. So that would be when x equals 4. But remember, for x-intercepts, how do we want to write our answers? As points, right. How many points should I be writing then? 2. The y value on both of these points is what number? 0. Because we put a 0 on for y. 0, 0, 4, 0 are my two x-intercepts. And then my y-intercept, let's see, y-intercept, we're going to plug in 0 for x. You can plug it into the original, you can plug it into the factored one. It shouldn't matter. They should give you both the same answer when you plug in 0. Let's see, 0 plus 3, 0 minus 3. What is the numerator simplified to? 0. What is the denominator simplified to? Negative 9. And what is 0 divided by negative 9? 0. So what should be the y-intercept? 0, 0. How should we have already known that? Because the x-intercept was at 0, 0. If the x-intercept is at 0, 0, then this is actually an x and a y-intercept. Because that's the origin. So it's going to cross both axes. We're not asked to graph. Hallelujah. Looking at the second one, what are we going to start by doing? Factoring. We want to factor it first. Very good. Y equals, on the top, I got some easy factoring. Get my little notepad handy. Okay. Very good, Nick, because we need two numbers that multiply to negative 6. They also need to add to negative 1. Those two numbers, same again, Nick?
X minus 3, x plus 2.
Minus 3 and 2. Minus 3 and 2. Excellent. So my numerator is going to be x minus 3, x plus 2. The bottom was that super, super easy type of factoring that everyone always overcomplicates because they think it should be more complicated. But what does it only have? Take out an x. Right. GCF of x. What's going to be left if we take out an x?
X plus 5.
X plus 5. Good. Okay, again, we're just asked to find the vertical asymptote, the x and y intercept. So for vertical, we're going to set the denominator equal to 0. And again, there's two factors in that denominator, which means how many vertical asymptotes are we going to have? So there's two factors. How many vertical asymptotes are there going to be? 2. One when x equals 0. One when x plus 5 equals 0. So one of them is going to be at 0. What's the other one going to be at?
Negative 5.
Negative 5. There are the two vertical asymptotes.
So 0, 0, and 0, negative 5.
Do I have to write them as points or do I write them as equations?
Points.
For a vertical asymptote? Remember, an asymptote's a line, equation. I know it's hard. There's so many of these, it's hard to keep clear sometimes. X-intercept. How do we find that again? Set y equal to 0. Good. And we kind of learned already, what's the shortcut? just the numerator equals 0, right? Because the denominator is going to cancel. If you find yourself not remembering that, just write the whole thing, and then you can actually see the denominator canceling.
So 0 equals to x minus 3x plus 2.
Mm-hmm.
So
Hold on. Because your denominator is going to cancel. And then over here, it's going to turn to 0 when you multiply by 0. So you're really just taking the numerator and setting it equal to 0. Which means we're going to have how many x-intercepts? 2. 1 when x minus 3 equals 0. 1 when x plus 2 equals 0. So 1's at 3, 1's at negative 2. Do we leave the answer like this?
no, you have to make it point.
Right, these are the ones we want to make points because the intercept is an actual point on your line. What are those 2 points? 3, 0, negative 2, 0. Very good. And then lastly, the y-intercept. We're going to plug in x equals 0 into our function. You can plug it into the original, you can plug it into the new one. You should get the same answer both ways. Hmm, 0 plus 5. Okay, this one is, yes, because on the top you would have negative 6. On the bottom you'd have 5 times 0, which is 0, and Nick says that's undefined. Yes, because you can't divide by 0. But if I say, where is the y-intercept, and you say, oh, it's undefined, what is kind of a more accurate way of saying that? It's not, there isn't one. You would just say there's not one. There's, no, not even no solution. You would just say there's not one. None. NA. Undefined. Can't divide by 0. So the y-intercept, none. There is another piece of information that we already found on this problem that should have told us that we weren't going to have a y-intercept.
There's no word?
No, not one. No, the x-intercept has nothing to do with our y-intercept. The vertical asymptote. Noel, what vertical asymptote? The x equals 0. Where is the vertical asymptote at x equals 0? It's on which axis? It's the y-axis. So if you have an asymptote on the y-axis, are you going to cross the y-axis? Nope, not going to cross the y-axis. It's kind of little piece of information that we'll see. They'll be like, oh, that's going to tell me something later. All right, on the back side. Brand new information. If you are factoring and you find a factor that cancels, so say you're factoring and you get something like this and you're like, oh, all those x plus 7s would actually cancel out. What you get in that spot is a hole in your graph, like an actual little hole in your graph. The technical name for a hole is called a removable discontinuity, and then you push your glasses up. Removable discontinuity. I will refer to it as a hole, though.
Nobody cares about removable discontinuity.
Right. Yeah, then when you go to calculus, they'll probably refer to it as removable discontinuity. So looking at this, the x plus 7 would cancel. Okay. In this case, x plus 7 is not going to give you a vertical asymptote because it's no longer on the denominator. But what you will have instead is a hole when x equals negative 7. So it's kind of like if you were to take that little canceled factor and set it equal to 0 and solve it, you would get negative 7. And that's where the hole is going to be at. So instead of having a vertical asymptote at negative 7, we would have a hole when x is negative 7. But it does make a hole when x equals negative 7. And then what that gives you is what's called a reduced function. It's like the new and improved, way simpler function. Do the x's cancel out on this new and improved, way simpler function? Do the 9's cancel out? No. But this reduced function, you get to find all the other information with. It's usually easier to work with. Everyone should be joyous about that. I look forward to holes because it means I'll have a simpler graph. I'm going to highlight an important piece of information here. When a factor cancels, just like it did here, you will use the new function to find all the important information. I promise you, people forget about that and they're using the old function, finding all kinds of wrong information and extra information. Everybody highlight that part? Good job, good job. We are still going to need to factor. Okay, so we're going to start by factoring. For each of the following, we're going to find the key features, including any holes. And again, we want to factor first. Okay. On the numerator, that looks like some easy factoring. I believe we actually even had this exact one already. Two numbers that multiply to -6, but add to -1. -3 and 2. We did do that one already. X minus 3, x plus 2. Bottom, though, is not an easy factoring. It's one where we're going to have to split the middle and factor by grouping. I'm going to do this on my scratch paper because I hate when my notes start looking messy. I'm going to do it over here. 2x squared plus 9x plus 10. So remember, for split the middle, you're not looking for two numbers that multiply to c. You're looking for two numbers that multiply to a times c, which would be 20. And they need to add to b, which should be 9, which is 4 and 5. Good. And then do those go straight into our parentheses? No. What do we do with them instead?
2x squared plus 4x
You remember. Good job. Man, Nick, you must have had a great Algebra 1 teacher.
Yeah.
Plus 4x plus 5x plus 10. And then what do we do after that? Put in parentheses. Put the first two in parentheses. Put the last two in parentheses.
And what's inside the other two parentheses has to be the same thing for two.
Yeah. So we're looking for the baby GCF of this first group. What is it? 2x. And then if I divided them both by 2x, what am I going to have left? X plus... Oh, x plus 2. Yeah, come on, brain. X plus 2. There. That looks like a 2. I was going to use whiteout, but this is yellow paper. On the back parenthesis, what's its little baby GCF? 5. So we'll write positive 5. If we divided both by positive 5, what's left? X plus 2. At this point, the parentheses match. Is that a good sign? Yes. If they didn't match, that means you did something wrong. So on the bottom, one of my factors is going to be 2x plus 5. 2x plus 5. Along with an x plus 2. And we should have some bells and whistles going off in our head. Why? We can cancel a factor. What does that tell me? There's a hole. A removable discontinuity. Yes, so we'll have a hole at x equals what? -2. Good memory. Okay. Hole at -2 comma something. I'm going to show you how to find the something in just a second. I'm going to write my reduced fraction first that I'm going to use to find all my other information. I just have an x minus 3 on top. I have a 2x plus 5 on the bottom. I'm going to circle this, highlight this, whatever you need to do to remind yourself this is the one that you use everything for now. The other one is dead. No longer exists. Penelope, are we doing things we're not supposed to? Can you put that in your backpack, please? Gosh, how azul of you. I've never played on my phone. Okay. How do you think we would find the y value of the hole?
We put the x in.
We plug the x in to where, though? To the original or the new one?
Oh, the new one.
The new one, right, because it's always use the new one for everything, including the y of the hole. So you're going to plug in x equals 2, or -2, to new function. And that should tell you what its y is. So I'm going to have, let's see, -2 subtract 3 on the top. And on the bottom, we'll have 2 times -2 plus 5. So the numerator is going to simplify to -5. The denominator is going to simplify to -4 plus 5, which is 1. So -5, 1. Is that what y'all got?
Yeah.
Okay. -5 over 1 would be -5, so I have a hole at -2, -5. If you were to graph that, you would just graph like a little open dot where -2, -5 is. Okay, after that, I'm going to find my vertical asymptote. using my new and improved, easier function, what are we going to do? Set the denominator equal to 0. So I'm going to have 2x plus 5 equals 0. Trying to solve for x, let's see, I can subtract 5 on each side. I'll divide by 2. So x equals negative 5 over 2. Or you're welcome to write this one as a decimal if you want to, since it's a terminating decimal. Yay, only one vertical asymptote. I'm going to skip horizontal asymptote. We'll do horizontal asymptote all on the back page. You will be sick of it. So we're skipping it for now. We'll go into x-intercept and y-intercept. X-intercept is found when what equals 0? The y, which technically your shortcut is. No, you were right. Your shortcut is when your numerator equals 0. Because you end up multiplying by the denominator, it ends up canceling. So you get 0 equals x minus 3, which means x equals 3. But wait, do we want to leave it like this?
No.
No, we're going to write it how? As a point, 3, 0. Okay, and then lastly, my y-intercept is when x equals 0. This one we're going to plug in 0 for x, but remember we're plugging into the new and improved reduced function. So we'll have 0 subtract 3 over 2 times 0 plus 5, which is negative 3 over 5. And then we'll just write it as a point. What are we going to get? 0, negative 3 fifths. There it is. We found all of our important information, including where the hole was at. Don't be scared of holes in your functions. Again, they create easier functions to work with. That's a good thing. Everyone got the first one? What are we going to start by doing on the second one? What are we going to start by doing? Factoring it. Good. The top's pretty easy. That's an easy factor. Goodness, Nick, you're so fast. All right, Nick already told us our two magic numbers are negative 5 and 2, so x minus 5, x plus 2. I know you're probably scared of the bottom one, but we've learned this already. We did it in Unit 4 when we learned how to factor polynomials. I'm going to remind you of the two methods we know to factor a polynomial. Let's see. Do y'all remember the two methods? Grouping. Good job, Dana. Grouping. And then if grouping doesn't work, your only other option is to make a list of your P over Qs and start using synthetic division. Gross. Boo. So we're going to cross our fingers and hope and pray that this one works with grouping. Okay, so let's see. For grouping, basically for grouping, it's like you split the middle, except the middle was already split. So you just go right on into, you're going to group the first two and group the back two. You're going to look for, what is the baby juice you have with the first group? X squared. And then if you divide out an x squared from the first parenthesis, we have an x plus 1. Negative 4, x plus 1. Which means these two factors are x squared minus 4 and x plus 1. But there's more. Anyone see that there's more? The x squared minus 4 is what type of quadratic?
Oh,
It's a difference of squares, so it will create its... It has its own two little factors because it's a difference of squares. So I'm going to transfer these three factors over to my denominator. X minus 2, x plus 2, x plus 1. And now that we see all those factors, Nick said we can see that there is a hole. Here. No one else? Just me? He said, I said there is, and he goes, a hole. No? Okay, I'll laugh. I'll laugh. Y'all don't have to laugh. Nick didn't even know he made a joke. A hole at what x value?
-2.
Negative 2 again. Are they always at -2? No. Just so happened on these. I'm going to write out my reduced function. Are y'all slowly getting the joke? Or no, people are still working on it?
You got it, bro.
Oh, okay. Thank gosh. Man. Thought y'all were a little slow for a second. -2 is the x value. How do I find the y value?
You plug in -2.
Plug it in to my new and improved reduced function. Remember, the original is dead. It's gone. Okay. So let's see. I'm going to have -2 minus 5 on the top. On the bottom, we'll have -2 minus 2. And -2 plus 1. So what is that? A -7 on the top. And -4 times -1, which is a 4. -7 over 4. Good thing we don't have to grab it. Okay. Again, we're skipping horizontal asymptote for this notes. We'll pick it up on the second notes when we see there's actually a few different options. Vertical asymptote, though, that's when we take our new and improved denominator, we set it equal to 0. How many vertical asymptotes will there be? One when x minus 2 equals 0, one when x plus 1 equals 0. So one at 2, and the other is going to be at -1. Good job. Okay, still using the new and improved function, we're going to go and find our x-intercept and our y-intercept. Alright, x-intercept, that's when your y equals 0, and you should know the shortcut by now. If y equals 0, your denominator is going to cancel, so you can really just do your numerator equals 0. Because when you multiply by the denominator, it's going to go away on both sides. So we get 0 equals x minus 5, which means x is 5, but we don't want to leave this answer like this. How do we write it? 5, 0. Good. And then lastly, my y-intercept. That's when x equals 0. So plugging in 0 for x into the new and improved function here, here, and here. 0 minus 5 over 0 minus 2 times 0 plus 1, which is a -5 on top, and a -2 times a 1 on the bottom, so a -2 on bottom, which would technically turn into what? Just 5 over 2. Those negatives would cancel. So you'll have a y-intercept at 0, 5 halves, or 0, 2.5 if you prefer. Alright, in the next lesson we are going to actually be getting into graphing some of these. You're going to miss